if 125 milliliters of a 1.25 molar calcium sulfate solution was reacted with excess potassium phosphate, how many grams of calcium phosphate would be produced? The first thing I see in this problem is a reaction that needs to be balanced. So I start with the calciums, and I notice that I have 1 calcium on the reactant side, but 3 on the product side. So I need to put a coefficient of 3 in front of the reactant calcium. That also means that I now have 3 sulfurs, and I need a coefficient of 3 in front of the potassium sulfate in order to balance the sulfurs as well. Now, doing that has given me 6 potassiums, so I'm going to have to add a 2 in front of the potassium phosphate in order to have 6 potassiums on the reactant side. And lastly, I have 2 phosphoruses, and I have 12 plus 8, so 20 oxygens on the reactant side, and I have 8 plus 12, or 20 oxygens on the product side. They were balanced by the time I got there. Okay, so now we can look at the actual numbers in the problem. And as I look at it, I notice a molarity. So the equation for molarity is molarity equals the number of moles divided by liters. Things that I can go ahead and plug in are the 1.25 molar concentration. My volume needs a little conversion though. So 125 milliliters is converted to liters by realizing that there's 1,000 milliliters in 1 liter. We end up with 0.125 liters. So to solve for number of moles, we simply bring the 0.125 liters to the other side, and multiply it by the 1.25 molar. So 1.25 times 0.125 gives me 0.156 moles of calcium sulfate. But we're not done yet. First thing that I notice is that that's not the chemical the question asked about. So I need to do a little stoichiometry. I can take my 0.156 moles of calcium sulfate, and I need to convert it into moles of calcium phosphate. Now, these numbers for how many moles of each chemical are going to come from the balanced chemical reaction. The coefficient of 3 in front of the calcium sulfate means that we have 3 moles of calcium sulfate for every 1 mole, because a blank coefficient is the same as a 1 of the calcium phosphate. Now, if the question had asked for moles, we'd be done and we've just finished our calculation. But we need grams of calcium phosphate. So we need to convert from moles of calcium phosphate to grams of calcium phosphate. To do this, we use the periodic table, knowing that 1 mole equals whatever we add up in terms of molecular weight for this compound. So we have 3 calciums, we have 2 phosphoruses, and we have 8 oxygens. So if we go to our periodic table, we can see that calcium weighs 40, phosphorus weighs 31, and oxygen weighs 16. And if we add these all up, 3 times 40 plus 2 times 31 plus 8 times 16 gives us a molecular weight of 310 grams per mole. Now, we're in the units the question asks for. We can pop in an equal sign and do some math. So, we take our moles of calcium sulfate, that would be divided by 3 times 310 grams, gives us 16.1 grams of calcium phosphate, which would be our final answer. Now, some people may be wondering, why did I use the 0.15625 rather than just simply 0.156? In this course, I would accept either number. They might be slightly different at the very end, but I give some accounting for rounding differences, whether you round all at the end of the problem or if you round as you go. Your number may turn out slightly different, but that's okay.